We're solving problem 17 from the 2024 F equals MA exam. Consider the following system of massless and frictionless pulleys, ropes, and springs. Initially, a block of mass M is attached to the end of the rope, and the system is in equilibrium. Next, the block is doubled in mass, and the system is allowed to come to equilibrium again. During the transition between these equilibria, how far does the end of the rope where the blocks is suspended move? Now, let's just start from the basics. These K's are the spring constants. These three springs. There's one right here, and then one right here. Now, this is a straight line, and now, all these T's show the tensions, the tensional forces in between all of the frictionless stuff. And now, all these Y's show the forces and the directions of the forces, where we have these two general forces. So the first thing to notice is that, we can say that our tension T is equal to mg, mass times gravity. But we can then say that T prime, or our next T, has an increase in mass since it is 2 times the mass. So this is 2 mg. Therefore, our change when you subtract these two, this is going to be the change. So there's negatives. This is mg. Now, here we can use conservation of springs, where we notice that there's this y sub p force just moving down. And this is magnitude that is moving down. How much? It is equal, so there's going to be 2 of those on each side. And so when you add those up, that's 2yp. And they have to be equal to the respective length these two springs stretch on top. But first, we can write that, this base notation is denoted by y sub, say, I. This is equal to mg over a constant k of I. Now we can get back here. So, therefore, we can say that 2yp is equal to y1 plus y2. And this is true because yp descends that total distance. It descends times that. So it's got to be equal to the increase in length for those two springs. Now, in this bottom lower part, there's got to be a decrease in y of p. And there's also a decrease in y, an increase in y of 3. So we can say that the magnitude in which y happens, this is going to be, there's the 2yp pushing down on it, but then you have to add the y of 3 pushing up on it. And this, since we have 2 y's of p, is y1 plus y2. This is y1 plus y2 plus y3. And when you plug these values into this thing that we just derived earlier, we can get a value for y, where y is equal to 11 over 6 times mg over k. So that is simply our answer for this problem.